Alright, so today we're going to be talking about Module 17.2, which is stretching, compressing, and reflecting quadratic functions. So from our graphing before, you guys know what vertical stretch, vertical compression is, something that makes it narrower or something that makes it wider. And you guys all know what a reflection is. So if you take a look at the first one on letter A, I've already completed that graph, and then I graphed it. And you can notice that this is a reflection. Sorry, that was terrible. It is a reflection right there on the x-axis. So whenever you have your parent function f of x, your g of x is just a negative x squared. Whenever it's a negative x squared, it opens going down. So we'll discuss that a little bit more too. Now what we did here is our a is just a 2x squared. So we put a 2 in front of it. So, and we'll talk about what happens, but this one, just by using the XY chart, it makes it vertically vertically stretched, so it's more narrow. All right, so with the width of a parabola, so for the parent function, f of x equals x squared, if a is greater than 1, it's going to be narrower. And if a is less than 1, it's going to be wider. So that's the absolute value of a. So positive or negative. So here's an example here. Vertical stretch. So your a is going to be greater than 1. So it becomes, the green one is more stretched. The blue is your parent function. So the green one on the vertical compression, the blue is the original, your parent function, and your green is more compressed. Think about one of those videos on YouTube where they do the hydraulic press with different objects and how they kind of get smushed. That's more of a compression. Another easy way to do this is to go on Desmos, and you can just type in f of x equals ax squared and put a slider in for a. So right here is your parent function. Now, as a gets larger, if you notice, it gets more vertically compressed. And I have it set only to go up to 10. So if you look, anything greater than 1 is going to be compressed. Now, if you're going to go between 0 and 1, that's going to be compressed. Anything greater than 1, is stretched. Anything between 0 and 1 is compressed. Now, same thing. If we have f of x equals negative 1 x squared, if you look here, it just opens the other way. Now, if it's between 0 and negative 1, that's going to be vertically compressed, so it's going to be wider. And anything smaller than negative 1, like negative 2, negative 3. So if you look, they keep getting vertically stretched. So I hope that helps, and log on to Desmos and just play around with it so you can see what happens there. So when your a is 0, it's just nothing. All right. So back here. So the width of a parabola. So what we were talking about is if your a is greater than 1, it's going to be stretched. And if your a is between 0 and 1 or 0 and negative 1, it's compressed. So the easiest way to actually graph these is to you can make an XY chart. So if you look here, g of x equals 3x squared. So here's our x values. They did negative 3, negative 2. You don't have to do that many values. Me personally, I usually do like negative 2, negative 1, 0, 1, and 2 as my starting point. And if I need more, I can always do more. But just by looking at this, g of x equals 3x squared, you can tell that that's going to be vertically stretched. So our blue one that's our parent function. And if you look at the green, it is vertically stretched. Now for letter B, they did an XY chart and they graphed these. And the parent function is blue, so f of x equals x squared. And your new function, g of x, equals 1/3 x squared. So you notice 1/3 is between 0 and 1. So it's going to be more compressed. It's going to be wider than the parent function. So if you look, the blue is the parent function, and the green one is a little bit wider. So that is a compression. So if you look at 2 and 3, all you're going to have to do is make an XY chart. So you can do X, Y. And I would do -2, -1, 0, 1, and 2. So the 1.5 is greater than 1, so it's going to be vertically stretched. Number 3 should be compressed. So I'll let you guys answer those. Okay, so now we have to graph, which is just with negative numbers. It's going to be the same exact stuff, but instead of opening going up, it's going to open going down. So if you look at, so it's the same exact stuff, it just opens the opposite way. So for a, the parent function is the blue one, f of x equals x squared. So here's your parent function. Now this negative in front of it, so this negative that's in front of that a means it's going to open going down. And all you're going to have to do is plug in. So -3 squared is -3 times -3 is 9. 9 times -2 is -18. So that's how you can graph for letter A. And then letter B, you can tell that that's also going to be a compression because it's -1/2. So it's between 0 and -1. And then it's going to open up going down. And like I said, if you ever need to, just go on to Desmos and you don't feel like graphing, let's do -0.5. There you go. So you can graph that. Or if they look, that was for the second one. If you look here, g of x equals -2x squared. So we'll just go back here and we'll just change our slider to -2. And then you can graph right there. It's a little weird on the iPad. It won't let me actually on the number. But yeah, use your graphing calculator. This will be a lot easier. And if you wanted to use it to graph instead of making an XY chart on a few of them, go for it. I would still recommend doing an XY chart. But if the graph helps you, use it to double check or use the graph. All right, so now we're going to go on to writing a quadratic function given a graph. So I did include the rules in your notes, but you can write a function rule for a parabola with its vertex at the origin by substituting the x and y values from any point into the parabola into your f of x equals ax squared and solving for a. So the first thing you have to do is change that f of x into a y. So you're going to need a y equals ax squared. So now what you have to do is, by looking at here, take one of the points on the graph. So they have a point at 2, -1. So we have 2, -1. So that's going to, 2 is our x, -1 is our y. So we're going to plug our -1, substitute that in for the y. -1 equals, a is what we're solving for, and we know what the x is, so 2 squared. So then, oh, sorry, that's going to be times 2. 2 squared. So what we're going to have to do is just solve for a. So 2 squared is 4. So you're going to get -1 equals a times 4. Then divide by 4, divide by 4, -1/4 equals a. So the rule is f of x equals -1/4 x squared. So that would work with any points on this graph. If you wanted to do right there, 4, -4. Let's try that one. So we're going to have y equals a times x squared. And it's going to be at 4, -4. Or 4, -4. So our x is 4, which is going to go right there. And then our y is -4, which that goes here. So -4 equals a times 4 squared. 4 squared, which is 16. So -4 equals a times 16. Divide by 16. Divide by 16. A equals -1/4. So it doesn't matter which point you use, you're going to still get the same answer. And then when you finish that, it's going to be f of x equals, your a is -1/4 x squared. And that's it. That's going to be one of the harder parts of this module 17.2. But it's really not that bad if you just use the formula and then you substitute in. So we'll look right here at the your turn. So we have 2, -3. So it's going to be y equals ax squared. So our y is -3. -3 equals a times 2 squared. So you guys know 2 squared is 4. So -3 equals a times 4. Now you divide by 4. Your a equals 3/4. So you're just going to have to write a rule. So it's going to be f of x equals -3/4 x squared. And that's your rule there. So if you have any questions, please feel free to reach out to me and I can help you out. I usually record a video for you to talk you through the steps, or if you want to live chat through Zoom or Google Hangouts, I'm available. So please let me know if you need any help. Thanks.